Okay, so I have now a perpendicular bisector. Okay, it's perpendicular because it's 90 degrees, and if I pull out my protractor, which is stuck to the ground, or to the table, there we go. I pull out my protractor, voila, 90 degrees, excellent. It is bisector because it is exactly halfway between my line. What about if I want to bisect this angle? This angle. What am I going to do then? Jackson?
Put a line in the middle of the angle.
There's a line in the middle of the angle.
Okay.
You guys are getting that you have to be specific with me, right?
Okay. So the angle would be like this. Put a line right in the middle.
Okay, how am I going to know where to put my line?
You
I mean-
start at the center. You would start at the center like almost measure.
Okay, but how do I know where exactly is in the middle of this line?
Protractor.
Okay. Ginny, what do I do?
You protractor and measure the degrees and then you divide it by 2.
Okay, so if I make this, if I look at this, it is 75 degrees. When I pause like this, it's usually because I'm waiting for you to correct me. Why is there no way that this could be a 75-degree angle? Ginny.
Because it's obtuse because it's more than 90 degrees.
Yeah, so it can't be a 75-degree angle. 75 degrees is less than 90 degrees. This is an obtuse angle. What did I do? What mistake did I make when I was measuring this? Haley.
You weren't measuring on the inside.
Yeah. I measured with the number that was closest to where I was. I didn't pay attention to which zero line I started at. I didn't start at the outside zero line. I started at the inside zero line, which means that I need to follow the inside line to get 115 degrees. So it's not 75, it's actually 115 degrees. Okay, and then I divide that into. Oh, come on. No. We're going to do this without a calculator. What's 100 divided by 2?
50.
What's 10 divided by 2? What's 5 divided by 2?
2.5.
What's 50 plus 5 plus 2.5?
0.5. I mean 50.7. 50.5.
57.5. So I get my protractor out. Am I measuring on the inside or the outside?
Outside.
Outside?
Inside one. Which one?
Inside one. Okay. So 55, 1, 2, 57 is going to be right there. How am I going to know if this is bisected? Yes.
Measure the angles with your protractor.
Yeah, I measured this angle, and I know that's 57.5. So this one, 57.5. So this one has to be what? If it's truly bisected, what does this one have to be?
57.5.
The exact same, yes. Okay, so 57, well, but 57.5 is all the way over here.
That's the
But you have to do it on the
obtuse side.
Oh, you mean I'm supposed to be following here? 57.5. The reason I do that, it's not actually to be annoying, although I'm sure it seems that way.
Very annoying.
It's because that is one of the most common mistakes students in grade 7 make with protractors. They don't pay attention to which side they should be measuring, whether they should be measuring on the outside or the inside. They get the wrong answer, and they don't think about it. The way you guys didn't, when I wrote down 75, you're like, oh, she's a teacher, she must be right. Okay, first of all, yes, I'm the teacher, but I'm human, and I'm going to make mistakes. And you guys can let me know when I do. Second of all, sometimes I make the mistakes that I have had students make so that hopefully someone will step in and say, no, that's actually not right. Here's what you did. Here's why it's wrong. Here's why you got it wrong, and here's what you need to do in the future. Because then you guys are all getting that. All right. There are other ways to bisect lines and angles. Does anyone know another way? Bria?
Could you like the horizontal line? Could you go through that with the line?
That, you mean to bisect the angle or to bisect? It won't bisect the angle, because if I went through the horizontal, I can do it like this. That's still going to bisect, but it's this part that's bisecting. This here is not bisected from here to here, although from here to here should be. Why? Oops, there. Why should this angle and this angle be the same? Ginny?
Because in order to be a full circle, it has to have 360 degrees.
Yeah. A full circle is 360 degrees. Okay? If we have taken this and this, we've taken a piece of that pie out. Okay?
No,
Here. I'm going to draw another one.
no, not the pie.
Okay? We have, from the center of the circle, removed this. If we then cut the circle in half here, we are not only cutting these ones in half so that those angles are equal, we've also cut the other side in half so that those angles are equal. Okay? All right.